This is the 0654, I think this is summer 25, question paper 6.1, and we're looking at question 5. These are always about the physics papers, just to be clear, physics questions. Although any skills here can be used for biology and chemistry. If you've tried the question, please crack on. If you haven't, please make sure you've done it, and then you can have a look at my answers and see if we can sort of discuss any skills, etc. Okay, so like I say, I'm assuming that you have done the question. Let's get cracking on with the answer. So first ones, remember in alternative to practical, there's lots of nice simple marks. First one for you to look at is this one here. We're being asked to record the mass of these 6 marbles to the nearest 0.1 grams. You are given an answer here to the nearest 0.01 grams, and so you are expected just to make sure that you write down a sensible answer, 37.1. My apologies, the resolution's not very clear there. Okay, this is all we're doing is rounding to the nearest gram. All right. As I say, alternative practical, there's lots of nice little marks. There are some nasty marks as well. Okay, this is one that you should be able to get. Just read the question nice and carefully. Okay, we're going to move on. Scrolling down. Okay, we're then looking at measuring volume. Now, whenever I see this picture, I always think about sort of just good practice. Whenever we're measuring the volume, okay, we're looking at measuring the volume to the bottom of this thing, the meniscus. Okay, so I've drawn an eye there. I didn't really need to, but I just do it anyway, just to confirm what I'm meant to be doing. And let's look at the questions. First one says, record the volume to the nearest 0.5 centimeters cubed. Now this is a slightly harder one, okay, in that you'll notice that each of these divisions, 1, 2, 3, 4, 5, is 1 centimeter cubed, and we're being asked to measure to the nearest 0.5. So if you go in here, you can notice that the bottom of the meniscus is at the position somewhere between 21 and 22. So if we want to go to the nearest 0.5 centimeter cubed, this is going to be halfway between 21 and 22. That is 21.5. Okay. Now the reason that it's not 22.0 is because we measured to the bottom of the meniscus. This little bit here is not relevant. Okay. All right. We're then told that the reading on the measuring cylinder is, after adding these 6 marbles at the beginning, is 39.0. Now I've circled this just to highlight one thing. Whenever we're measuring things, we give it to the nearest smallest division. So we can measure 39.0. Notice that when we write that down, it is not 39, it is 39.0. Okay, because we're working in 0.5s, so we go 0.5, 0.0, 0.5, 0.0 in terms of our precision. Nice, simple calculation. We're being asked to calculate the volume of the glass marbles. Nothing difficult. They tell you the equation. They tell you Vm equals 39.0 minus V1. And we end up in a 17.5. Now, obviously, this 17.5 depends on the value that you got in the previous question. If, for example, you entered 22.0 here, which would be if you'd measured the wrong parts, right? Measuring that the top of the water, not the bottom of the meniscus, you'd still get a mark as long as you calculated things correctly. So do not stress about this too much, okay? As long as you've calculated, there's an error carried forward mark here too. Okay, so far so good. That's 3 marks, which I think are fairly simple. Okay, we're then asked to calculate the density, all right? But we are also asked specifically to give to 3 significant figures. So you're given an equation, all right? You know the equation M, and we've got our numbers M and V, M, and all we've got to do is put those numbers in. Now notice, there's a 2-mark answer, okay? 2 marks here. This can confuse students a little bit when we do these kind of calculation questions in your paper 4. You get 2 marks for knowing the equation and writing the answer. For this one, it's about getting the correct answer. That's 1. And then also for the significant figures, making sure that your significant figures are correct here. In this case, 3 significant figures. What I do is I write out loads of significant figures, and then I round it to the nearest, to the appropriate significant figures. I've seen this for 2 as well. All right, now, here's what I'm noticing is a really interesting development in paper 6. We've got a teacher doing the same experiment and calculating the density. Okay, fantastic. Obviously, teachers are always right? And it then says here, 2 values are considered to be equal within the limits of experimental error if the difference between them is less than 10%. Okay, what we're going to do is we're going to basically compare this 1.81 to the 2.80, and you can see quite clearly they are very different. Okay, now previously CIE did not tell you the 10% number. They just said, are they equal or not? Now they are saying very clearly that if you want something to be equal, it must be within 10%. So you need to now explain, based on the information you got here, all right, if these two values are equal. Well, you've got to justify it with a calculation. So in this case, I've calculated the percentage difference. I've taken 2.80, 1.81, calculate percentage difference, and I've got 35%. Now, sometimes students will put the 1.81 on the bottom here. That's also fine, okay? Either way is fine. You'll notice that the 35% is greater than the 10%, which means we can consider these guys to be equal numbers, okay? In physics, whenever we want to check if something is equal to another one, we will calculate their percentage difference, and then compare it to 10%. Okay, now I've seen questions which are 35%. I've seen questions which are 5%. I've also seen questions which are 11%. Okay, so that's very close to 10, and it's where you have to make a decision. Basically, as long as you justify it, you should be fine. All right, let's move on. Okay. Now, I did this before, okay? It says describe how the student measures the volume of the water accurately using that measuring cylinder. This is what we should be doing. Draw the measuring cylinder, very simple, eye level with the meniscus, okay? Very common thing to talk about in chemistry as well, biology as well. Whenever we're making measurements, we put our eye to the bottom of the meniscus, we make sure it's level with the bottom of the meniscus, and then we read from there. Okay, keep that one in a bank of kind of improvements because it's always something that you can rely on. All right, we've now got another student does the experiment and uses the balance, and we notice that this is the balance before any glass marbles are added. Now this is a problem. This is what's called a zero error, and because there's nothing on here and it should read 0, but it does not read 0, i.e. there is an error in the readings. Now you think about this, if I add something on, it's going to go up, but it's going to be too big. How big is it? How much? What's the difference between those numbers? It is 0.60 big, too big. All right, so it's added an extra 0.60 onto every mass value. So it says here, state why this balance does not give the correct reading, and suggest what we do to obtain an accurate mass of the glass marbles. I find this question structure a bit odd, so I'm just telling you here. Okay, doesn't give the correct readings because the readings will be, whoops, I've written too big, T-O-O big, by 0.60. This is a zero error. The apparatus has not been zeroed. Well, a suggestion as to what they could do to obtain an accurate mass, well, we could just subtract 0.60 from all the mass values, right? If I have a mass which is 1.60, then I'm going to have to take off 0.60 to get 1.00, all right? Or we could press the 0 button on the scales, right? There's a 0 or a tear button, which can always be pressed, and that would be a good one to include. Okay. Oh, that's the end of that question. All right. So there's lots of common points here. Okay, lots of criticisms, bits about reading to the meniscus, and then this thing here. I would end here. This is our really big point here. If you don't know how to do these percentage calculations, please do practice them, and I'll make sure there's a few more recorded as we go.